Hi, we are back in Module 9. We are nearing the end of our module. This time we are covering pages 300 to 303. And we're talking about the different kinds of covalent bonds. There are purely covalent bonds and there are polar covalent bonds. And today we're going to have another example of polar covalent bonds. So we have polar covalent bonds continued. Remember that in a polar covalent bond, the electrons are shared, but they are not shared equally. Okay, they're in between these two atoms, but they get pulled to one side more often than they get pulled to the other because the one atom is more electronegative. So again, the electrons are shared, but they're shared unequally. For example, we're going to do another example, this time of water. Okay, let's practice drawing the Lewis structure for water. We have hydrogen with one valence electron and another hydrogen with one valence electron, and we have oxygen with 1, 2, 3, 4, 5, 6 valence electrons because it is in column 6. So that's how we know how many valence electrons there are. Okay, the atom that has the most unpaired electrons is in the middle. Oxygen has 2 unpaired electrons. Hydrogen only has 1, so oxygen is in the middle. So we can start with oxygen here, and we can see that these 2 electrons could be shared to form a covalent bond. And then we can see that these 2 electrons could be shared to form another covalent bond. So we draw it like this. 1 covalent bond, 2 covalent bonds, and then oxygen still has those 2 non-bonding electron pairs. Okay, so our Lewis structure for water would look like this. Now let's ask, where do the electrons spend more time? And we're going to add the partial charges. Remember in our last video, we learned this little symbol delta, which means partial or a small fraction. Okay? So hydrogen and oxygen don't pull on those electrons equally. Oxygen is farther to the right on the periodic table, which means it's more electronegative. So oxygen pulls more strongly on those electrons that are shared, meaning that the electrons spend more time around the oxygen, giving it a partially negative charge. The hydrogens spend the majority of their time without any electrons, so they have a partially positive charge. Okay? So when we add the partial charges, we just put them right next to the atoms, showing that they have a little bit of a positive charge or a little bit of a negative charge. Now we're going to use a new symbol. Use this symbol, an arrow with a little plus sign at one end, for covalent bonds in a molecule to indicate which way electrons are pulled. And the positive end stays by the positive atom. Okay, so for water here, this is just a way to be a little bit more detailed in our covalent bonds. This is a covalent bond, but if we add, or if we turn this into this symbol here with an arrowhead pointing toward the oxygen, it means that the electrons spend more time by the oxygen. And then a little plus sign is by the hydrogen, meaning that hydrogen often has a positive charge because it doesn't have any of the electrons by it. So we can make our covalent bonds more detailed by using those symbols. All right, let's try a couple examples. Our examples are from example 9.3 in your book. Which says to identify and label the polar bonds in NH3. Okay, so we're at example 9.3, and we need to identify and label the polar bonds for NH3. Okay, so the first thing we have to do is draw out the Lewis structure. Nitrogen will be in the center because it has the most unbonded pairs. It has it has 5 valence electrons, but it has 3 unpaired electrons. So you can see that that is where the covalent bonds will come in for the hydrogens. So we can add the covalent bonds with the hydrogens. 1, 2, 3 hydrogens. So here are the covalent bonds. Are they polar? Yes, they are polar because the electrons are not shared equally between nitrogen and hydrogen. Who is going to tug more strongly on those electrons? Look at our beloved table. Hydrogen is over here way on the left and way at the top. Nitrogen is farther over to the right, so nitrogen is more electronegative, meaning nitrogen has the stronger pull on those electrons. So to label the polar bonds, we put the arrows pointing toward the nitrogen, and we put the positive ends toward the hydrogens. That's how you do that one. The next example in 9.3 is C2F4. Drawing this Lewis structure is a little bit more complicated, so let's practice that together first. There are 2 carbons. Carbon has 4 valence electrons. And there are 4 fluorines. Fluorine has 7. Okay, so there are our Lewis structures for the individual atoms. Now, how do they bond together? Okay, well, we can see that each of these fluorines can form a covalent bond between electrons there, for example, and let's use these up right here together, and then this fluorine can pair up with this carbon, and this fluorine can pair up with this carbon. Okay, we know that the carbons are going to be in the middle because remember you have to look at which atom has the most unpaired electrons, and carbon had 4 unpaired electrons. Fluorine only has 1. So the carbon atoms are going to be the central atoms in the molecule, okay? And then the fluorines will attach on the ends of the carbons. Okay, so now the carbons each have 2 electrons left looking for a partner. So these 2 could share, and these 2 could share, meaning there's going to be a double bond in between the 2 carbons. So it's going to look like this. Carbon double bonded to carbon, and then a covalent bond to fluorine, a covalent bond to fluorine, and the same thing on this side, 2 covalent bonds to fluorine. And then let's add our extra valence electrons for fluorine. Would have 6 more around each one. Okay, so here's our Lewis structure. Now we're supposed to label the polar bonds. These are shared electrons here, so they are covalent bonds. They are not shared equally, so they are polar covalent bonds. Okay, so who's got the stronger tug, the carbon or the fluorine? Look at your periodic table. Carbon is in column 4, fluorine is in column 7. So fluorine is farther to the right, meaning it has a higher electronegativity. So fluorine has the stronger pull. So our covalent bonds are all going to be pointing toward fluorine with the positive end toward carbon. And that's all you have to do when you are asked to identify and label polar bonds. That would be what you would do. Okay, that's example 9.3. And that's the end of my video for now.